Let's learn one of the most important sorting algorithms asked in Java interviews, mergeSort. Imagine sorting a very large array with thousands or even millions of elements. Simple algorithms like bubble sort, selection sort, and insertion sort can become very slow because their worst case time complexity is O of n squared. mergeSort solves this problem using the divide and conquer technique. Instead of repeatedly comparing neighboring elements, it divides the array into smaller parts, sorts each part, and then merges them back together efficiently. That's why mergeSort guarantees a time complexity of O of n log n, even in the worst case. mergeSort works in three simple steps. First, it divides the array into two equal halves. Next, it recursively continues dividing each half until every subarray contains only one element. A single element is already considered sorted. Finally, it merges the smaller sorted subarrays back together by repeatedly comparing the first elements of each half and placing the smaller one into a temporary array. This divide and merge process continues until the entire array becomes sorted. Now let's implement mergeSort in Java. We begin by writing the mergeSort method. First, we check the base condition. If the left index is greater than or equal to the right index, we simply return because a single element is already sorted. Next, we calculate the middle index. Then we recursively call mergeSort for the left half and the right half. Once both halves are sorted, we call the merge method to combine them into one sorted array. This recursive approach continues until the entire array is sorted. The merge method combines two sorted halves into one sorted array. We create two temporary arrays to store the left and right halves. Then we compare the current elements from both arrays. Whichever element is smaller is copied into the original array and its pointer moves forward. Once one side is exhausted, we simply copy the remaining elements from the other side. This merging step is what makes mergeSort efficient while maintaining the correct order of elements. One of the biggest advantages of mergeSort is its predictable performance. The best case, average case, and worst case time complexities are all O of n log n, because the array is always divided into equal halves and merged back together. However, mergeSort requires additional memory for temporary arrays, so the space complexity is O of n. This extra memory is the trade-off for its guaranteed performance. Here are some important interview points to remember. mergeSort uses the divide and conquer strategy. It is a stable sorting algorithm, meaning equal elements keep their original order. Its time complexity remains O of n log n in every case, making it much more predictable than quicksort. Because of its stability, mergeSort is commonly preferred for sorting linked lists and for applications where maintaining the relative order of equal elements is important. If you found this video helpful, like, subscribe, and follow Java Visualized for more Java interview questions explained visually.